Hello, boys and girls. Tomorrow you have your first test, our Unit 1 test. It will cover squares and cubes, perfect squares and perfect cubes, as well as being able to simplify cube roots, estimate cube roots, and there'll be some evaluation as well. So let's break out the notes and go over the notes as well as the study guide, and we're going to work through some sample problems together. Let's get started. Okay, boys and girls, let's break out our study guide as well as our notes, which will be handy. If you look at the first page of the study guide, you'll see list the first 15 perfect squares. I'm not going to go over that with you. You just need to know that. That will be on the test tomorrow. That's 15 points of the test. Let's go to the second part, Roman numeral 2. It says identify, simplify each perfect square root. The first one starts out simple. It says, what is the square root of 25? And you guys should all know that that is 5. You can go through this entire list. When you get to the bottom row, then you see things switch up a little bit. Okay, this time they're saying, the square root of what is equal to negative 14? I don't see if that problem is on is 1, 2, 3, it's four rows down, and it is in the second column. Okay, so what you have to ask yourself is, the square root of what would give me negative 14? Well, I know if I square negative 14, I'll get 196, and that's exactly the answer. And keep in mind, anytime you're finding the square root, technically, there's two answers. For example, the square root of 25 is 5 or negative 5. Okay, but usually we just go with our positive answer. And then there's also a challenge problem in there, which says, what is the square root of negative 16? And in order to figure that out, I have to take negative 16 and multiply it by negative 16. And 6 times 6 is 36, carry the 3. 6 times 1 is 6 plus the 3 is 9. Put a 0 there as my placeholder. 1 times 6 is 6. 1 times 1 is 1. I add it all up, 6. 9 and 5 is 15. Carry the 2. We get 256. And yes, that is a positive. That is a positive because a negative times a negative is a positive. Let's look at part 3 on the study guide, identify and simplifying each perfect cube. Let's take a look at the second one there. What is the cube root of 27? Which is simply asking what times what times what, here's our three factors, is equal to 27, the number inside of the radical. So we want to figure that out. And each of these numbers, each of these factors have to be identical. And sure enough, if we were to put 1 in here, 1 times 1 times 1 would be 1, that's not it. 2 times 2 times 2, that's 8. But 3 times 3 is 9, times 3 again is 27. So the answer is 3. The cube root of 27 is 3. And once again, we have one that's a little backwards here. They're saying the cube root of what number would be equal to negative 4? Okay, so they're asking the cube root of what number, okay, this is the mystery in here, is equal to negative 4. Well, they're giving us the three-peat factor of negative 4. Okay, negative 4 times negative 4 is going to be a positive 16. Then bring my next negative 4 down. And now, a negative 4 times 16, well, it's going to give us a negative answer. 4 times 6 is 24. Carry the 2. 4 times 1 is 4, plus the 2 is 6. So we get a negative 64 as our answer. Let's take a look at some sample problems from Roman numeral part 4. We see simplify each expression. Let's start with the first expression, number 1. It asks us for what is the square root of 49 plus the square root of 121. That's simple enough. The square root of 49 we know is 7, because 7 times 7 is 49. and the square root of 121 is 11. Okay, we just follow order of operations. These radicals are really exponents. They're negative exponents. So we do the radicals first, and whichever radical comes first, we did first, and then we add. Okay, we got the radicals out of the way. 7 plus 11 is 18, and we are done. Let's take a look at number 7. Number 7 looks like fun. Here we've got the square root of the difference of 130 minus 9 plus the square root of 49. Okay, well, 130 minus 9 is going to be 121. Okay, now somebody might be saying, I thought we're supposed to do the radical first, not subtraction. Well, we are doing the radical first, but inside the radical we have a subtraction problem, so we have to solve that. Okay, now we can begin to solve the radicals. The square root of 121, which is 11. The square root of 49 is 7. We add these two together, we get 18. Let's make some room here. Get them out of the way. Okay, let's do number 8. Number 8, I think, is a good one. It says, this is what's written down for number 8. Now, it's very important that you can read this properly. Okay, we have a number squished up against a radical, and anytime you have a number squished up against a radical or even a variable, we know that the operation between here is not addition, it's multiplication. It's always multiplication. Okay, so you would read this 9 times the square root of 121. Okay, which comes first, radical or multiplication? The radical does. So the square root of 121 is 11, and then we have to bring down the rest of the information. 9 times 11, which is 99. That was easy enough. Let's take a look at number 10. We're doing quite a few of these. The square root of a fraction. The square root of 121 over 81. Well, we would treat this just like the square root of 121 over the square root of 81. The square root of 121 is 11. The square root of 81 is 9. And we get 11 ninths. And you could clean that up. We know that that would be 1 and 2 ninths if we were to turn it into a mixed number. Boys and girls, let's move on to part 5, estimating square roots. And let's take a look at a very interesting square root. We want to find the square root of 95. Well, we know the first step, if we want to estimate to the nearest hundredth, is we have to find the nearest whole. And I know that the square root of 95 is somewhere in between the square root of 81 and the square root of 100. Okay, the square root of 81 would be 9. The square root of 100 would be 10. So 95 has to fall somewhere between 9 and 10. And to be quite honest, 95 is closer to 100 than 81, so I would have to say that the square root of 95 is approximately 10 if I was going to the closest whole number. But if I want to find to the nearest hundredth, okay, I have to do a little more work. There's another step. Okay, what I want to do is I want to take the difference of these two numbers, and which would be 95 minus 81, and divide that by the difference of these two numbers, which would be 100 minus 5. Now this is the way we would normally do it, but the problem is when we have 95 minus 81, we're going to get a difference of 14, and here we'll get a difference, whoops, that's 95, of 5. Now anytime that we get an improper fraction, that's where the numerator is larger than the denominator, we need to switch it up. We need to invert it. We need to get the reciprocal. So we're going to change that to 5/14. Now that's what's different, and that's always going to happen when our whole number estimation is our larger number. Okay, so we know that when we find the difference of these two squares and the difference of these two squares, we're going to have to flip our fraction, change it to its reciprocal. Now I can divide. I take 5 and divide it by 14, 14 will go into 50, I think, 3 times. 3 times 4 is 12, carry the 1. 3 times 1 is 3 plus the 1 is 4, so I get 42. I subtract and get 80. Bring down another 0. Well, I get 8, I'm going to make it 80. 14 will go into 80 about 5 times, which I know is 70, and I can stop right there. Now hold on, normally we would take this decimal and add it to the 10. Let's think about that. The square root of 95 is somewhere between 9 and 10. If I add 35 hundredths to 10, that's going to take me outside of that range. I know that the square root of 95 is very close to 10, but it's got to be a little under. So adding 35 hundredths to that will not help. We need to subtract. So if I take 10 and subtract 35 hundredths, that's going to give me a very close approximation. I have to do some borrowing here. This 0 borrows from that, I can't borrow. But this 0 can borrow from there, so this becomes 0, this becomes a 10. Now this 0 can borrow from 10, and the 10 becomes a 9, and this becomes a 10. And this 0 can borrow from this 10, and it becomes a 9, and this becomes a 10. Okay, 10 minus 5 is 5. 9 minus 3 is 6. Bring down my decimal point, and then I bring down the 9. And my final approximation is 9 and 65 hundredths, which is a very close to the actual. Well, that's all I have for you today. Make sure that you look over the study guide as well as your notes and do your very best tomorrow, and please get a good night's rest. I'll see you tomorrow, and good luck on the test. Bye-bye.